Hi, my name is Saumya and I'm learning Python to enhance my coding skills. For loops. In the last chapter, we added the if statement to our skill set, enabling the computer to choose which set of code to run. In this chapter, we learn how to loop. Rather than have our programs run straight though, we can run a section of code however many times we like. This chapter covers for loops which allow us to loop a certain number of times. The next chapter covers while loops which will loop until a certain condition, such as game over, occurs. Introduction to looping. Most games loop. Most programs of any kind loop. Take for example a simple number guessing game. The computer thinks of a number from 1 to 100 and the player tries to guess it. This is an easy game to program on the computer using loops. Start with code that will take in a guess from the user and then tell the user if they are too high, too low, or correct using the if statements we learned about in the last chapter. Then we just need to loop through that code until the user guesses correctly or runs out of guesses. Here's an example run of just such a program. Wait. What does this simple text game have to do with advanced graphical games? A lot. You may be familiar with the frames per second or FPS statistic that games show. The FPS represents the number of times the computer updates the screen each second. Each frame in a video game is one time through a loop. The higher the rate, the smoother the game. Although an FPS rate past 60 is faster than most screens can update, so there is not much point going faster. The figure below shows the game EVE Online and a graph showing how many frames per second the computer displaying. The loop in these games works like the flowchart in this figure. The inside of these loops have three common steps. 1. Get user input. 2. Perform calculations. 3. Output the result. Then we loop this 60 times per second until the user asks to close the program. There can even be loops inside of loops. Take a look at the Draw Everything loop flowchart below. This set of code loops through and draws each object in the game. You can put this loop inside the larger loop that draws each frame of the game. There are two major types of loops in Python, for loops and while loops. If you want to repeat a certain number of times, use a for loop. If you want to repeat until something happens, like the user hits the quit button, then use a while loop. For example, a for loop can be used to print all student records since the computer knows how many students there are. We could wait for the user to click the mouse button with a while loop because we don't know how many times we'll have to loop before that happens. For loops. This for loop example runs the print statement 5 times. It could just as easily run 100 or 1,000,000 times by changing the 5 to the desired number. Note the similarities of how the for loop is written to the if statement. Both end in a colon and both use indentation to specify which lines are affected by the statement. Go ahead and enter it into the computer. You should get output like this. Try adjusting the number of times that it loops. The I on line 1 is a variable that keeps track of how many times the program has looped, sometimes called the counter variable. It is a regular variable and can be named any legal variable name. Programmers sometimes use I as for the variable name because the I is short for increment. And that's often what the variable does. This variable helps track when the loop should end. The range function controls how many times the code in the loop is run. In this case, 5 times. The next example code will print please 5 times and can I go to the mall only once. Can I go to the mall is not indented and so it is not part of the for loop and will not print until the for loop completes. Go ahead and enter the code and verify its output. This next code example takes the prior example and indents line 3. This change will cause the program to print both please and can I go to the mall 5 times. Since the statement has been indented, can I go to the mall is now part of the for loop and will repeat 5 times just like the word please. Here's the output of that program. You aren't stuck using a specific number with the range function. This next example asks the user how many times to print using the input function we talked about last chapter in the input function. Go ahead and try the program out. You could also use what we learned about functions and take in the value by a parameter as shown in this example. Using the counter variable. You can use the counter variable in the for loop to track your loop. Try running this code, which prints the value stored in I. With a range of 10, you might expect that the code prints the numbers 1 to 10. It doesn't. It prints the numbers 0 to 9. It is natural to assume that range 10 within parentheses would include 10, but it doesn't. In computer programming, we typically start counting at 0 rather than 1. Most computer languages use this convention. An old computer joke is to get your friend a mug that says, "World's number 1 programmer." Then get yourself a mug that says, "World's number 0 programmer." If a programmer wants to go from 1 to 10 instead of 0 to 9, there are a couple of ways to do it. The first way is to send the range function 2 numbers instead of 1. The first number is the starting value. The second value we'll count up to, but not equal to. Here's an example. Give it a try. It should print the numbers 1 to 10 like so. It does take some practice to get used to the idea that the for loop will include the first number, but will not include the second. The example specifies a range of 1 to 11, and the numbers 1 to 10 are printed. The starting number 1 is included, but not the ending number of 11. Another way to print the numbers 1 to 10 is to still use range 10 within parentheses and have the variable I go from 0 to 9. But just before printing out the variable, add 1 to it. This also works to print the numbers 1 to 10, counting by numbers other than 1. If the program needs to count by 2s or use some other increment, that is easy. Just like before, there are 2 ways to do it. The easiest is to supply a third number to the range function that tells it to count by 2s. See this code example. The second way to do it is to go ahead and count by 1s but multiply the variable by 2, as shown in the next example. Both examples will output the numbers 2 to 10. It is also possible to count backwards. For example, 10 down to 0. This is done by giving the range function a negative step. In the example below, we start at 10 and go down to, but not including 0. To include 0, the second number would need to be a -1. We do this by an increment of -1. The hardest part of creating these backwards counting loops is to accidentally switch the start and end numbers. Normal for loops that count up start with the smallest value. When you count down, the program starts at the largest value. If the numbers that a program needs to iterate through don't form an easy pattern, it is possible to pull numbers out of a list as shown in the next example. A full discussion of lists will be covered in the Introduction to Lists chapter. This prints nesting loops. By nesting one loop inside another loop, we can expand our processing beyond one dimension. Try to predict what the following code, which is not nested, will print. Then enter the code and see if you are correct. Did you guess right? It will print 3 A's and 3 B's. The next block of code is almost identical to the one above. The second for loop has been intended one tab stop so that it is now nested inside of the first for loop. It is a nested loop. This changes how the code runs significantly. Look at it and see if you can guess how the output will change. Did you guess right? We still get 3 A's, but now we get 9 B's. For each A, we get 3 B's. The outside for loop causes the inside code to run 3 times. The inside for loop causes its code to be run 3 times. So 3 times 3 is a total of 9 times to run the innermost code. Complicated? Not really. You've already lived a loop like this. This is how a clock works. The 1 to 12 hour is the outside loop, and the 0 to 59 minute is the inside loop. Try this next example and see now how it prints all the times between 1:00 and 12:59. Later on in clock example with leading zeros, we'll show how to format the output and make it look good. Keep a running total. A common operation in working with loops is to keep a running total. This running total code pattern is used a lot in this book. Keep a running total of a score. Total a person's account transactions. Use a total to find an average, etc. You might want to bookmark this code listing because we'll refer back to it several times. In the code below, the user enters 5 numbers and the code totals up their values. Note that line 1 creates the variable total and sets it to an initial amount of 0. It is easy to forget the need to create and initialize the variable to 0. Without it, the computer will complain when it hits line 4. It doesn't know how to add new underscore number to total because total hasn't been given a value yet. A common mistake is to use I to total instead of new underscore number. Remember, we are keeping a running total of the values entered by the user, not a running total of the current loop count. Speaking of the current loop count, we can use the loop count value to solve some mathematical operations. For example, check out this summation equation. If you aren't familiar with this type of formula, it is just a fancy way of stating this addition problem. The code below finds the answer to this equation by adding all the numbers from 1 to 100. It is another demonstration of a running total is kept inside of a loop. Here's yet another example of keeping a running total. In this case, we add in an if statement. We take 5 numbers from the user and count the number of times the user enters a 0. Review. In this chapter, we talked about looping and how to use for loops to count up or down by any number. We learned how loops can be nested. We learned how we can use a loop to keep a running total.